I'm happy to present our today's speaker, Sergey Snigirevsky, who will talk about Archaeopteris. Sergey, please.
Yes, yeah, thank you. Thank you very much. So my presentation is about the new reconstructions of Archaeopteris trees from late Devonian all over the world. So, and I'll try to explain you some of our investigations. And before I must excuse for my bad English because I have no practice in speaking about 5-6 years. I don't know. So, well, we begin. That are 7 parts of my speaking, of my presentation. They are here, and we began from the information for all the people, because not all of you knows these two genera, familiar, and not all of you knows that that is one plant in geological past. So, well, Archaeopteris and Calixula. Archaeopteris foliage was described firstly described in the middle of 19th century. It was very usually foliage of different types of leaves. Some of leaves were sterile, and some of leaves were fertile. So, like here, there are a fertile part in on the rachis. It means that time that it was firm. Later, in the beginning of 20th century, Mikhail Zalesky described a new form of dadoxylon from Donetsk Basin near Razdolny village. The former name of this village was Karakuba. Later, 2 years later, Zalesky understand that that's not dadoxylon wood, and it's separate genus. He gave this for this wood name of Calixulum, and Calixulum tephili is the type specimen of this genus. So, and in 1960, Charles Beck, American paleobotanist, understand that Archaeopteris and Calixulum are the same, are different parts of the same plant. It was very big success in understanding of the nature of these ancient plants. So, and in 1983, Yves Lemoine and his Russian colleagues, Alftina Yurina and Natasha Snigirevskaya, published revision of the genus of Calixulum, and here you can see they write Archaeopteris like an synonym of the genus Calixulum, but the genus Archaeopteris was published previously, and in this case, Archaeopteris is the name for the plant of which had foliage of Archaeopteris type and wood of Calixulum type. Here is an example of distribution of different localities of Flammenian woods. There are here a lot of European forms and American. There are in South Africa, in Siberia, and here is not in Siberia is Frasnian locality. Well, very long time. One means that Archaeopteris calyxylon were the first plants which formed the fossil forest on the Earth. But about 10-15 years ago, different our colleagues established that the first forests were formed not by calyxylon but by different plants, by Pseudosporochnus and Vatieza, etc. So, and we observe the records of Devonian fossil forests on the Earth. It's our second part of our talking. So, one of them. There are a lot of publications about first forests, about the importance of calyxylon in the forming of first forests. But Alevtina Yurina, Russian paleobotanist, she was died 2 months before our speaking now. So, and her 2 last publications were dedicated to first Devonian forests on the Earth. She classified all the Devonian fossil forests and write two very important articles, but in Russian, and these publications are not so widespread like different English publications. So, but I think that these 2 articles are very, very important, and I hope that our colleagues will read these articles in Russian with translator, because there are classification of different fossil forests on the Earth. So, according to Urina's data, there are 5 known Devonian fossil forests in the world, and 3 of them are from Middle Devonian and 2 of the Upper Devonian in age. So, but one of the Urina's conclusion was that Devonian forests have not been established in Russia. So we will talk about this too. So that are different localities with rests of ancient forests. By 3 angles, there are 3 Middle Devonian. That are 2 Pero and Gilboa in North America. There is Lindlar in Deutschland, in German. Munindalin on Spitsbergen, Svalbard, and the 5th one is Xinjiang, Xinjiang. I don't know the spelling. Xinjiang, I say so. I think so. So, well, later we will talk about 2 our Russian fossil forests, North and Middle Timanian in age. So, it's here. Middle Aphelin, Middle Devonian, yeah, the oldest fossil forest in Lindlar, Germany, in Mühlenberg-Schichten, Middle Aphelin. This forest was dominated by Calmaphyton primella. The other one is from North America. I know about it by Chris Berry's information, materials, who he shows me at the time of his visit to Russia. So there are different root systems on the flat, and that are two prevalent forms that are Eospermatopteris or Archaeopteris and Archaeopteris trees. Very similar is Gilboa fossil forest of the Middle Devonian, late Juvatian, like in Cairo. But this forest was formed exclusively by Vatieza or Eospermatopteris. So, leucopsid fossil forests of early Friasnian age from Spitsbergen was dominated by arborescent leucopsids, Protolepidodendropsis. And Chris Berry with colleagues reconstruct this small part of this fossil forest. And then late Famennian fossil forest of Xinjiang was dominated by Guangidodendron micro. It's arborescent but very small leucopsids, which are the dominated form in these fossil forests. So in this after this explanation, you can understand that three of forests formed by Pseudosporachnalian doxylopsids, I think so, yeah, are from Middle Devonian age. And Upper Devonian, Late Devonian age are exclusively two arborescent leucopsids forests. So, but our investigations shows that not all the fossil forests in the late Devonian were of leucopsid nature. It is the fossil forest on Tsilma River. It's middle Timanian ridge, river Tsilma on the left and right banks of this river. There are about 25, maybe 30 stumps, but not stumps.
Okay, Sergey, you may continue.
Yeah, well. So, yeah, there are different root systems on the sandstone without fossil soils. It's very important. It means that this forest was very left very short time, yeah, because no fossil soils were here established. It's the view on this fossil forest from the quadricopter. There are different systems on this place. It's that are the small piece of this fossil forest, because here in lower part it's covered by sediments, and here it is destroyed. Yeah, only this small could territories with stumps. Yeah. So well, the other one, fossil forest of Famennian age, was established and studied by us colleagues in Volga River. It's northern Timan. There are three vertical in situ fragments of Archaeopteris trees of Kalixin-Zalesky type of anatomical structure. Here you can see these scan photos, 5 and 6. And first one is small stem of Calixulin trifilii of anatomical structure. And here we find the foliage of Archaeopteris macellenta, very usually type of foliage which connected all the time with Calixulin wood. So, and now we return to the localities of Devonian fossil forests that are here in the European part of Russia. And here is more very detailed map of this region. This left arrow means the Silma River fossil forest. It's Frasnian in age, and this one is Volga River, and this is Famennian in age. So two fossil forests are established on the territory of European part of Russia. Then now we will talk about the Archaeopteris roots in ancient soils. Sure, Archaeopteris, like one of the first forest-forming plants, must be very good soil formers, because at the time of beginning of plant life on the earth, before the invite of the plants to the land, there are no very good and good formed soils, and roots of and rhizomes of different plants were very, very short and about 1, 2, 3 millimeters deep. So here's a very good diagram of relative size of penetration depth in root systems. We talk about the Juvetian and Frasnian and Famennian part of this diagram, and the first time when I saw this schema, I think that it's not so not really. It's drawn not really like child by pencil, yeah. But our investigations as a result of our investigation, we understand that it's maximally right. It's classic and sure saw. So the most famous stump of Calixulin we know from Oklahoma state in United States, Calixulin whiteanum. It was very, very big, and many of our colleagues knows only one stump of Calixulin tree. But not all the colleagues knows that in the classical locality of Kalixilon in South Donetsk basin, near of Razdolna village, in Razdolna formation, it's Upper Devonian. There are very, very rich locality with stumps and trunks of Kalixilon trees. In 1979, 1981, it means about 45 years before, Natalia Snigirevsky, famous Russian paleobotanist, organized different expedition to find the pieces of Kalixilon trees in the type locality. I was there like volunteer, it's me, here on the left side of this photo, and we gathered the method of selecting fragments and combining them into the most complete plant remains. So we prepared all the woods of Kalixilon from the stones around of them, and labeled all the pieces with numbers, then packet all the pieces together, and then in St. Petersburg, former Leningrad, we connect all these pieces into the one plant, and as a result, it was a very big collection of different type of fossil woods of the genus Kalixilon. So it's the explanation of this work. So it's the schema in the field diary. It is photography in 1980 year. So, and this is the piece of Kalixilon wood, but that are roots of Kalixilon. So, and as a result, we made the not reconstruction, but the full stump of Kalixilon tree. It is now in Komarov Botanical Institute, in the Botanical Museum of this institute, and it is one of the important findings of these woods, because it shows different type of stumps of Kalixilon. This is one, yeah, and this is the second. Please don't forget about these different types of stumps, yeah. Very, very close in nature and morphology. The stump was found now by our we find in North Timan in 2016. Very, very similar, yeah. And there are a lot of fossil soils on North Timan localities with fossil soils and in situ root systems. Here, especially here, you can understand that this diagram, this painting is very, very right. Yeah, you can see in the flattened roots on one level, which are going from of this vertical root. So rosette-shaped flattened roots. And here are different morphological types of root systems of Archaeopteris trees, which we discovered in different years on Timanian localities. So, and branch abscission was very a characteristic feature for Archaeopteris trees. It was firstly identified by Charles Beck, and in very, very big and famous work of Mary Trivet, it was further investigated, and we thought that it was a main feature of Archaeopteris trees. And in this case, we hypothesized that fallen branches were as a resource for increasing of humus and mineral content in the poor soils, nutrient poor soils. So we can talk about that later if you have questions, yeah? But it's our idea, and it's very important, I think. So another one very important moment is that in all observed cases, the diameter of the root systems of Archaeopteris was very small, yeah, and the diameter of the crown of these plants was well, the same. I think so. I think I'll say so. Not I think, I say that it was about so. So that's about Archaeopteris roots in fossil soils. So now about new trunk discovery. Very big trunk, about 2 meter high or long, was discovered by our colleagues Vadim Glinsky and Daria Pinakhina in Devonian sediments near of St. Petersburg. And this trunk was collected and very, very delicately prepared and photographed. And now we have the full image of this trunk. Yeah, there are here aerial root, 2 branch scars. One is true, and another one is probably, and 2 lateral branches. So, well, about these parts of this finding. And the first time about the specific identity. About 10 years, we tried to find the piece of this stem where we can find the anatomical structure. And after about 15 or 20 repeated attempts, we can find very small piece of the wood which was not cross-sected, because on the cross-section there are no anatomical features. but we find pieces which were identified on the scanning electron microscopy. We have here radial section of tracheids with apertures, yeah, and grouped or cohortoid porosity on the radial walls of tracheids. The same photo, yeah, and in this case we identify this fossil stem as Calixulin conformis nephili. So above the branch pattern, yeah, so it's perennial tree branches of the genus Archaeopteris. It's established the first time, and that are two branches, two lateral branches. So then we have very important part which are identified by us like branch scar. So you can see in moment here, yeah, you can see this branch scar. It's photo of this branch scar with separating layer, which explains that this branch was followed after the preparing procedures of this plant. Yeah, it was not traumatic. Then we have another possibly branch scar. Here it is on the something upper than the upper division. Yeah, the upper division. Yeah. So the presence of lateral appendages was established. Here you can see at the time here and here, yeah, you can see this piece of maybe aerial rod, because this branch, not branch, yeah, going out, going down, not up on this stem. So, and based on this data, we can we understand that we must create new reconstruction of this plant. So, because before we will we'll talk about our reconstructions, we must talk about the previous reconstructions of Archaeopteris plants. The first reconstruction was created by Seward in 1931. This time, Archaeopteris was regarded as fern, yeah, and here is a reconstruction of true ferns of Archaeopteris type. Later, 30 years later, Charles Beck, who established the identity between Archaeopteris and Calixulin, create new classical reconstruction of this plant. In all the botanical and paleobotanical textbook, you can see in this reconstruction. But at the base of this stem, you can see the Oklahoma specimen, yeah, and the branching pattern was not established and was doubled from the branching in the terminal branches. Yeah. So after findings of our expedition in 1979, 1981, after the composing of the stump of Calixulum, I showed that before. The new reconstruction of Calixulum was created by Natalia Snigirevskaya in 1984 with this very, very different type of stump. And this plant was, excuse me, this plant grows on very bad, very poor soils between stones and small and big pieces of rocks. On the between the roots, we find some stones which were enclosed by this plant during the time of its life. Yeah. Here, the branch pattern is different from Charles Beck's reconstruction. But this reconstruction was not so widespread known, because it was published in a botanical journal in Russian language, and not all the investigators know this reconstruction. So then in 1916, we suggest new reconstruction, like Frankenstein from two parts of Archaeopteris trees. One was with roots of Bonnet's type, and the crown of Charles Beck's type. Yeah. This publication was the same in Russian, and is also little known among specialists. So another reconstruction, like a fire tree by Deschler and Kressler in 2011. It's very, very different reconstruction, and very criticized by us, because there are no these fuchsias, for example, like traumatic branch foul. Yeah, it was not so usually for different Archaeopteris. Sure, we need, based on a review of existing reconstructions, and the new reconstructions is necessary for recent nature and for recent science. Yeah. And we need to suggest another reconstruction. But when we saw about the history, yeah, the first attempt of reconstruction of the plants in type locality of Calixulum was firstly made by Natasha Snigirevskaya, but it was not published. And I show you this painting by artist Arkadiev. He worked in Botanical Museum in Komarov Botanical Institute. And this is from archive of Natasha Snigirevsky, this reconstruction. It was never published, but on the base of this reconstruction, we create new reconstruction too. But when we try to make the reconstructions, we understand that that's impossible to create one reconstruction. We need two reconstruction because different parts of the plants are very, very different, but all the features, anatomical and morphological, and all the nature of these plants says us that there is maybe the same family, maybe the same genus, or maybe two different genera, yeah, or maybe different ecobiomorphs. And this term maybe is not widespread because it was just it was proposed by Lavrenko, Russian botanist, in 1965. And I think that it's better if you can read myself this the explanation of this term. So maybe these two different plants were one biological genus, but different ecobiomorphs, or maybe different genera, and in this case that are different plants. So the first reconstruction here is written about this reconstruction. First reconstruction based on the root system from Donets Basin, on the trunk of from Syas River near of St. Petersburg. Sure, we think about branch fall or cladoptosis, and the shape of macrophyllous leaves of Archaeopteris archetypus type. So, and with aerial roots of Radicetus devonicus type. This species was described by Sergey Snigirevsky in 2019, and these plants were about 4 meters high, and they grew on rocky, gravelly substrate in very, very fairly dry habitats. In this reconstruction on the left, in the very, very shallow water, you seen Linia Cubensis, Devonian, Devonian, Upper Devonian, Flaminian, lycopod, which formed this small small association in the on the beach of small water reservoirs. Yeah? So it's the first reconstruction of Archaeopteris or Calixtrian tree. Another one is reconstruction which is based on the trunks from North America and Northern Timor. of collection Zalesky type with the trunk of collection Whitean and foliage of Archaeopteris macilenta type. So, and you can see here the projection of the crown on the surface, and during the codaptosis or branch fall, the branches of this plant fell on the earth, and sure, they play very big, had very big importance for feeding, for input of feeding in the sediments which were very good drained. Yeah. So it's the second one reconstruction of Archaeopteris tree. And these two reconstructions were published in our article, which was published in Biological Communications. Here, in the bottom of this figure, you can find the site where you can find this article. So, and miscellaneous for people who is not trying to listening to me, it's news from today, yesterday, and the day before yesterday. Not far from St. Petersburg, my colleagues Anna and our colleagues from St. Petersburg University find a new woody stump of Devonian plant of maybe Juvetian, uppermost Juvetian, or maybe of lowermost Francian sediments, not far from St. Petersburg. And this stump is prepared now at this time, at the time of our lecture. And there are two fragments. It's the base of the trunk, so with very unusually transverse structures. So, and that is the prepared root of this big stump. So, that's our investigation about the Archaeopteris trees, about the first Devonian forest, and so I think that it's not so big time. No, I don't know. Excuse me. Well,
Thank you. Thank you, Sergey, for such a beautiful presentation, both for historical matters, for very new results and findings, and for beautiful illustrations. Now we have time for questions, and you may pose them in usual way, or you may write them in the chat.
Maybe.
And I see a couple of comments in the chat. One from Susan Renner, wonderful talk, Sergey, and one more from Haru Nishida. Thank you for the interesting and stimulative talk. Is it possible to paste the DOI of your new papers on new reconstructions?
Yes, I can. I don't know what is. What must I do?
You may send it to me, and I send to everybody.
Well, maybe
later.
Yeah? I don't know. Technically, I don't know.
This is Haru speaking. And if you can copy the DOI that appeared in your slide, you can just paste in the chat.
Yeah, I'll try. Just a moment. Yeah. I'll try. I don't know. Is it possible or not?
Otherwise, Natalia can send.
Okay,
Stop. Yeah.
Okay. Meantime, one more congratulations from Joseph Sanyan for your amazing presentation.
Thank you. Так, just a moment. Oops. Yeah.
Oh, it's coming. Yeah. I'll try.
Good. Yeah.
Well.
Yeah. It's
okay.
It's filled now. It's not.
Well.
Oh, yeah. It's finished.
Yeah, done.
Yeah, it works.
Yeah.
Well.
Thank you. I can see the site.
Good.
Well, more questions to our speaker. One more comment, or two more comments. Comment from Bruce Cornett. Excellent presentation. And from Alexis Rastiev.
Thank you.
Super presentation. Thank you for this talk. Well, I'd like to ask a question about the time of existence of Archaeopteris plants. When they originated and when they disappeared.
The time of life of these big groups, was from the latest Juvatian. It means the middle Devonian, till the early Carboniferous. It means about 27 million of years.
And if I may, one more related questions. Where did they appear? Where they appear geographically? And where they
all the world.
There should be one point to appear and then to disseminate, to widespread.
Yes, widespread. For example, South African colleagues find different pieces of Archaeopteris foliage and stems in Famenian of South Africa, and that time, according to reconstructions of Scotese or Scottis, different spelling, Scotese reconstructions, it was subpolar territories. So
the very first Archaeopteris, were they subpolar?
The first Archaeopteris, the first in Europe, in America, in Laurasia,
So thank you. And Federica Rossa writes a comment. Thank you for your beautiful work. It is beautiful when art can help science to help us to understand the past of our planet.
Thank you. Very good. But questions? There are questions, no?
Just comment. I do not see questions.
No questions.
How do you plan to study this freshest find?
Yes, is the earliest evidence. Yes. The earliest evidence in the history of woody plants. I think so. Yeah.
One more question from Evgeny. See in the chat, and I will read. The question is about falling adaptation branches. Is it true that this is the earliest evidence?
I said, it's the earliest evidence of branch fall in the woody plants. Yes.
Thank you. And Haru writes that he downloaded the paper successfully. Thank you for the paper. Well, I do not see more questions.
So maybe I will just a moment. I'll write my my email if
In the chat.
anybody
We
want
see.
to ask me, then you can write me on this address. So maybe anybody more
Well,
question? No?
I suppose that Alexey Vladimirovich.
Oh, yes, I would like to ask about the last appearance of Archaeopteris from the lower Carboniferous.
Lowermost Carboniferous.
From where they were recorded?
In Donetsk Basin too, because the sediments in Stila village territories, not far from Razdolne. It's about 12 kilometers far from Razdolne. There are sediments of different age, or uppermost Familian or lowermost Carboniferous. For example, young ones think that it's lower Carboniferous and not Turnesian, but maybe Visean. So, and in this case, this localities with Archaeopteris foliage and roots is lower Devon, is lower Carboniferous. Yeah. So.
Thank you.
Some localities in Europe, I forget where, I cannot say now true, yeah, but in Europe, one or two localities too, yeah.
Thank you. Well, one more question in the chat from Alexis Rastier. What about the other plants that lived in the understory of this Archaeopteris-dominated Pamenian forest? Do you have any record of fern-like plants like Rhacophyton?
Yeah, thank you very much. Just a moment. It's very good question. It's very good question. Yeah, just a moment. I'll show you one photo, one
do not
reconstruction made by Mikhail Shikhanov too. Yeah, just a moment.
Сереж, тебе нужно будет по новой поделиться экраном.
Yeah. I must find it. Just a moment.
Yeah, we're waiting.
Yes. So, for example, moment. It's a piece of our moment. No. Moment. Нет. Момент. О, так, да. И это сюда. Сейчас. Нет. Во. Нет. Excuse me, please. Just a moment. I can open it here, but I cannot find it in my computer. Just a moment. Here, yeah. What? Mhm.
Share the screen.
Yeah. I find it. Oops. Oi. Oi. Ay. What? So, доклад. What?
We do not.
What?
Okay.
Yeah, sure. So,
Mhm.
it's a 2016 year. It's a piece of our presentation with my colleague Pavel Biznosov. But here on the foreground, on the left, you can see Rakafiten in understory, yeah, and on the right side, you can see reconstructions of Archaeopteris before our constructions, yeah. So it's a reconstruction of Volga River valley.
They're
But
beautiful.
Volga, not ancient, not recent, but ancient, of Volga, Devonian Volga River. It was a very big complex of deltaic sediments. So, and here is Rakafiten, and on the diet pieces of Rakafiten branches, there are different maybe algae, I forget name. I forget. The same which was found in Spitsbergen on the branches, fallen branches of Rakafiten by Nathorst, described by Nathorst in 1904.
What kind of algae?
I forget this generic name. After COVID, I forget different families and terms. Yeah, it's my.
Anna Lubarova suggested caudephyton.
Not caudephyton. No.
Not caudephyton.
Just a moment. No, I can. Codonophyton. Codonophyton regeri. Yeah.
Thank you. Meantime, we have several more comments in the chat from Tatiana Stukova's superb presentation. Thank you for the talk. A comment from Bruce Cornett. Rakafeton ceritangium found living next to Archaeopteris in Famennian of West Virginia in 1970. I worked on reconstructing Rakafeton for my master degrees under Professor Henry Andrews at this organization. And one more question from Evgeny Karasov about falling branches. As far as I know, before that, the first evidence of falling branch was in conifers or is in some other gymnosperm groups.
No. Conifers began their life in Carboniferous, but not in Devonian.
Of course.
Gymnosperm groups, Archaeopteris firstly was placed by Charles Beck into the group of Progymnospermopsida. Yeah? Progymnosperms. This term was firstly introduced by Sapertai at Marion in 19 80
What's
years.
wrong with the sound?
So, and then Natasha Snigirevsky made new group of Archaeopteris Archaeopteridophyta, which is the separate group in the rank of type of division Archaeopteridophyta in 2000 year in Botanical Journal in Russian too. And this publication is not so famous and worldwide known. So
Thank you. And I suspect that it was the last question to the speaker. I don't see new comments.
yeah.
So thank you once again for your beautiful talk, for this
Thank you.
perfect mixture of science and art. Thank you for coming and speaking for us. Thank you everybody for coming.
Thank you.
Thank you very much. Very
Thank you,
interesting talk.
Natalia.
And goodbye.
Thank you.
Yeah,
Thank you
well,
for
Bye.
coming.
Well,
Thank you,
goodbye.
Natalia.
Bye bye. Thank you.
Bye.
Thank you. Thank you.
Thank you very much.